lost 45 cubic kilometers of ice since 2000, equivalent to 18 million Olympic swimming pools. The losses are accelerating, with annual melt rates increasing 57% between 2010 and 2020 compared to the previous decade. Some smaller glaciers have disappeared entirely. Satellite imagery confirmed 127 named glaciers under 0.1 square kilometers vanished between 2016 and 2021. Regional variations are also apparent. The Bernese Alps lost ice fastest, at 1.2 meters of thickness annually, while higher elevation Valais glaciers averaged 0.8 meters. Accumulation zones, where snowfall traditionally replenished losses, are shrinking. Satellite snow cover maps show these areas have contracted by 30% since 2000. The Finderland Glacier's accumulation zone retreated 400 meters upslope in just 20 years, pushing glaciers toward irreversible decline. Satellites also capture human interventions. High-resolution Maxar images show white glacier blankets covering 0.6 square kilometers of the Rhone. Glacier each summer, though surrounding unprotected ice continues retreating at 8 meters annually. Before and after images of the Triftsee Reservoir highlight how engineered dams attempt to replace lost glacial water storage, with its expanded capacity now holding 40% more meltwater runoff from the shrinking Trift Glacier. The satellite record confirms an undeniable acceleration. Annual ice loss rates tripled between 2000 and 2020 compared to 1850 to 2000 averages, according to Nature, published comparisons of modern data with historical maps. These orbital perspectives connect high-altitude changes to downstream consequences, like the Rhone River turning turquoise with fine rock flower weeks earlier than in the 1980s, or sediment plumes from glacial rivers extending 15 kilometers into Lake Geneva, threatening aquatic ecosystems. From space, the story of glacial decline becomes impossible to ignore. Downstream domino effects. The shrinking glaciers of the Alps disrupt water systems across Western Europe long before reaching the ocean. Glacial meltwater traditionally fed rivers during dry summers, acting as natural reservoirs that released steady flows when rainfall declined. Now, this centuries-old hydrological rhythm falters. Peak melt arrives months earlier, leaving less water when cities and farms need it most. The Rhone River carries 30% less water past Lyon during August compared to 1980s averages, while the Rhine at Basel shows 25% lower September flows. These shifts permanently alter the continent's water clock, with cascading effects on industries, agriculture, and daily life. Low river levels first cripple navigation on major shipping routes. In 2018, Rhine barges reduced cargo by 40% for 132 days, costing German industry €5 billion in surcharges. Near Kobe, operators now dredge 300 truckloads of sediment weekly to maintain navigable depths. Siemens Energy cancelled turbine deliveries in 2022 when barges couldn't pass this choke point. Swiss pharmaceutical giant Roche, facing similar disruptions, built new logistics hubs in Antwerp, adding 15% to supply chain costs. These adjustments highlight how industries reliant on river transport must now absorb higher costs and logistical uncertainty. Industrial water users face equally stark challenges. BASF's Ludwigshafen complex, the world's largest chemical plant, depends on Rhine water for both cooling and transport. During low-flow periods, managers must prioritize one function over the other, disrupting operations. French nuclear plants along the Rhone reduced output 12 times last summer when river temperatures exceeded 25 degrees Celsius, too warm for effective reactor cooling. EDF estimates these climate-related losses cost €330 million annually, prompting discussions about relocating plants to coastal areas where seawater cooling is feasible. Agriculture, too, struggles to adapt. Burgundy vineyards now install costly drip irrigation systems, a €12,000 per hectare investment that many small growers cannot afford. In Provence, the Lac de Serraponcon reservoir dropped 28 meters in 2022, forcing farmers to abandon 15% of irrigated fields. Italy's Po River Basin, where alpine sources provide 40% of summer flow, lost 60% of rice paddies during 2022's record drought. These losses ripple through rural economies, leaving farmers with fewer options and mounting debts. Municipal water systems also strain under these changes. Zurich invested €45 million in filtration upgrades to handle increasingly turbid glacial floodwaters, which now occur 3 times annually instead of once a decade. Geneva's tap water contains 40% more mineral sediment as melting glaciers grind bedrock faster. Smaller towns face harsher realities. Visp in Valais rationed water for 47 days last summer, banning non-essential uses like car washing. The Swiss Water Association reports 120 municipalities drafting emergency plans for glacier-free futures. These disruptions extend beyond infrastructure to personal lives. In Visp, a local farmer, Hans, described how water rationing forced him to choose between irrigating his crops or providing water for his livestock. "We've always relied on the glaciers," he said. "Now, I don't know how we'll manage if this keeps getting worse." Transboundary tensions also rise along shared rivers. France and Spain dispute management of the Tech River, fed by Pyrenean glaciers retreating 50% faster than alpine ones. Switzerland's unilateral water releases during droughts draw complaints from downstream German cities. "We can't sacrifice hydropower generation to solve Berlin's water problems," remarked a Swiss energy official during confidential negotiations. Hydropower systems face mounting strains. The Grand Maison Dam in France operated at 62% capacity last summer despite early meltwater surges. Operators must balance retaining water for winter electricity with releasing it to sustain river ecosystems. Switzerland's hydropower output dropped 7% during critical summer months over the past decade, pushing electricity prices up 12% in affected regions. Groundwater depletion compounds these issues. The Rhone Mediterranean Water Agency measured aquifers dropping 1.5 meters annually in areas historically recharged by glacial rivers. Lyon suburbs now extract 25% more groundwater than in 2000 to compensate for reduced river flows, a stopgap measure that risks long-term depletion. These interconnected disruptions reveal a hard truth. Europe built its water-dependent civilization during an anomalously stable climatic period. The next decades will test whether engineered systems can compensate for nature's lost ice reservoirs. As industries restructure and communities adapt, they follow patterns first set by species retreating uphill, except humans have nowhere left to climb.